Okay, my name is Dibakar Dhara and I belong to chemistry department from IIT Kharagpur, and I am going to teach you polymers. Okay. Now, obviously, first thing you will ask me what are polymers. You will also ask me why should you study. You also will basically come to know in this course that what are different types of polymers, which basically we mean that classification of polymers, and how these polymers are prepared, and we will also talk about some common examples of polymers and their applications. I will try to ask you questions and answer in between while teaching. Now, obviously, first question we will ask now that what are polymers. Now, when you attend school and you are in classroom, for example, and say you are in different benches. Now, if I ask you just that those who are belonging to a single bench, you just join your hands. So, each bench will form a chain of you. Okay. So, basically you will be connected by your hands, joining your hands, and if we imagine in this case that you are units, one units, then when you join and form a chain, we can imagine those are many of you, or we call this as a polymer molecule. Of course, in this case in a bench you will be 5, 6, 10. So, this is not true sense of polymers. In case of polymers, we talk about hundreds of molecules are joined together using covalent bonds. Of course, by this example you also will know that each units in these polymers, which we will call monomers, they must have two hands, basically two functionalities, which means that they should be able to form covalent bond from two sides. So, at least each monomer unit or the units from which polymers are made, they must have two functionality. So, if I just put it in pictorial form, if I just write this as a unit, monomeric unit, and then if I join these units one after one using covalent bond, the term covalent bond must be noted. Unless these are not joined by covalent bonds, we will not call this as polymers. Okay. Now, in this case we have single units which are joined together. You can also think of joining different type of units, like if I put a different color objects in between. And so on. So, in this case we are making a polymer from same units, we call this as a homopolymer, and in this case we are making the polymer molecule from more than one units, we call these are copolymer. And the units from which the polymers are made, they are called monomers, and when they are in polymer molecules chain, these are called repeat units. Okay. So, these are called repeat units, which are very close to the monomers. Sometimes it is just the monomers are added, and sometimes there will be some slight difference between the repeating units and monomers. We will see some examples. For example, I will talk about this monomer. This is a monomer, name is styrene, and then we form a polymer. This is a polymer and the name would be polystyrene. Now, this N, which is basically the number of repeating units this polymer contains, which basically that many number of styrene molecules had gone in the chain in making polymers. And the polymer molar mass could be as high as or in the range from say 1000 to the polymer molar mass could be 1000 to say 10 lakhs gram per mole, which means if I just consider that the repeat unit is having say approximately a molecular weight of 100, which means a polymer molecules generally contains somewhere between 10 to 10,000 number of repeating units. There are exceptions where it can go either of this side, but most of the polymers are formed with repeat units, number of repeat units would be between 10 to 10,000 basically. Some other example which is very common is polyethylene. So, you have ethylene, the monomer, and this is polyethylene, the polymer. Similarly, we can give other examples, like we can give a example of polyethylene terephthalate, which is in short called PET. You probably know lots of advertisement where they are saying that it is made of a PET bottles. So, it is polyethylene terephthalate. It is formed from ethylene glycol. So, this is ethylene glycol plus terephthalic acid. This forms a polymer which will have So, this will be the repeat unit in case of this polyethylene terephthalate. Now, in this case you will also notice that if I take n number of these and n number of terephthalic acid, then we will also produce water molecule. So, there is some fundamental difference between the way these two polymers are made. One case you do not see any small molecules coming out, just the molecules, monomer molecules are added, and in this case monomer molecules are reacted and polymer is formed, plus some small molecule comes out. We will talk about more about these two processes, we will name them, but time being you just give some examples of different polymers. Now, next question we had framed that why should we study polymer. Obviously, polymers are basically nowadays is very common. When you just think about life without polymers, that is practically impossible. You imagine what you do at the morning when you get up. First thing what you do, you take a toothbrush and start brushing, and the toothbrush is made up of plastics or polymers. And there are numerous examples starting from buckets, bottles and spectacles, whatever you basically do. Your clothes also made up of fibers which are polymers. So, if you think what you do from getting up in the morning and then just going to bed, every step, if you go out and take a cycle or to the school or you go by car, then you will see lot of polymeric materials are basically in those cycles or cars. These are very common example. We talk about commodity applications of polymer, but there are many advanced applications. You talk about space shuttles, rocket launches, they will also have plenty of polymer materials in them. Electronics applications, the CDs or the DVDs you buy, they are also made up of polymers. There are numerous medical examples. For you, if you think about the knee replacements or hip joint replacements, contact lenses, sutures, there is endless examples we can give. So, it is not only what I mean to say that it is not that only the bottles or buckets, toothbrushes which we commonly link with polymers or plastics, is not only those. Many high end applications, medical applications, electronics applications, space applications, you name the high applications, that those applications are not practically possible without the use of polymers. So, nowadays increasingly the polymers are replacing metals or woods in different applications. And for new application, if some company try to think about new product, then they first will think about the materials which are made up of polymers. If that is not possible, then they will go back to the other materials like metals, wood or ceramic and all these things. And we call the current age is a polymer age, and you probably know what are the earlier ages were. We started with Stone Age, where you have only stones for living, and then people came to know how to make copper alloys, and it is about 5,000 years back, and we basically have a Stone Age then, and then we basically went forward and then found the Iron Age. So, basically, and then after that we had about 1907 when the first commercial product using completely synthetic polymers came out, that is when the polymer age started. So, basically if we write those different ages, you have Stone Age, then Bronze Age, and then Iron Age, and then you have a polymer or plastics age commonly. So, with time we are moving from, and currently we are in this age. Now, what is the unique thing about polymers, which basically making the polymer molecules so much useful? There are very excellent properties in polymers. I will just try to note down few of them. So, basically why polymers is very much advantageous compared to other materials available is basically the foremost is it is lightweight, which means it has excellent strength to weight ratio, which means you can, if you want to make a product, you probably get equal strength of that product by using much lower weight comparative to a metallic substance or metallic compound substance or a wooden substance. And so, this is one of the most prime advantage. So, nowadays we are moving towards light, so that we can, like in cars we are moving to lightweight vehicles. Second is design flexibility. Which comes from low cost processing with high freedom of design and styling. Plastics gives you lot of freedom in terms of processing. You can process basically easily, quite cost effective way, and also you can design any materials, any different complex shapes, which is not possible for other materials like metals and ceramics. So, plastics gives you this design flexibility, which is which gives the advantage in case of polymers. Polymers are in general thermal and electrical insulator, which basically gives advantage for their use in thermal and electrical insulators for like wear coatings and so many applications where you require insulators, thermal and electrical insulators. Many polymer based products are optically clear. What does it mean? That you require applications where you need a clear. For example, I have a bottle in my hand. Obviously, if you want to see what is inside, whether the drinking water we are using, drinking, it is very clear and transparent, you probably want a materials, the bottle should you know, the bottle should be prepared with a clear and transparent material, which is not possible for metals or ceramics or other materials. Like the CD or DVD we talked about, has to be optically clear so that the laser can go through and read the data inside. So, there are many applications where you need, and also aesthetical, you always like clear products, it looks good. So, in terms of aesthetic also it is better to have optically clear products. So, it is not all polymers gives you optically clear, but there are many, you know, polymers which gives you optically clear materials, this which is also advantage, and you get lot of variety of polymers, you get lot of varieties in polymers, which basically makes anybody want to choose. Basically, if you, it gives you choice, like if you go in a shop and find dresses, and if you find there are many choices, any choice of colors and choice of brands, obviously we like to choose things from them, whereas the other materials do not give the choice. And the last one, obviously it gives a lower cost in most of the applications. Obviously, there are applications where you need polymers which are also costly, but in general polymers gives a lower cost. So, these are some of the properties, aspect of polymers which made polymer the material of choice, and we talk about the polymer age currently. So, that is why we should you know, as a general science student, we must have some basic knowledge about polymers, because it's such a common material nowadays, and we belong to polymer or plastics age now. We will also talk about, you know, polymer cycle. Now, I have just told you in beginning that we start with monomer, and what we do? We do convert the monomer to, we write capital letter, it will be easy. So, monomer to polymers, and this method of converting monomers to polymers is called polymerization, a polymerization reaction. Once the polymers are produced, you know, they can be in, depending upon what is the condition, they could be in solution. So, from which you can isolate the polymer and make polymer powder, or you can have this as such, you know, in bulk, which means you have the neat polymer in hand. So, no solvent was used. So, you get from directly from monomer to polymer by this reaction. Okay. Now, next, when you have the polymers in your hand, there are some applications where you use polymers as a one of the ingredients, like in detergents, medicines, paints, where you have polymers are added as one of the components. So, you can use these polymers which are you obtain by this post polymerization. So, you can add, and you can just have application. In this case, polymers are one of the ingredients of the product. Like just example, I said detergents, paints, medicines and so on. Most cases the polymers are used where most of the products is made up of polymers, but it is not 100%. So, basically what is done in the next step, polymers are taken and processed in first step. So, you get a intermediate products like pellets, powder or sheets. So, in this case what you do? You do a, so you can add additives in this case, which will require in making the polymer, like colorants and stabilizers, which basically performance enhances or just brings the look aesthetic look in the polymers. And then finally, you take this and further process and get the final polymer product. Now, these two steps, and put this in arrow, these two steps we call together, we call polymer processing, which basically once you have the polymer made, you are converting the polymers to the final polymer product by adding and some additives and doing some processing method of converting these polymers, raw polymers, to final polymer product. So, these two steps in combinedly called polymer processing. So, currently what is the problem? The problem is here and problem is here. Where from do you get the monomers? Most cases you get the monomers from petroleum products. So, basically crude oil, or anotherly we can say fossil fuel, which is not renewable. Basically with time we are depleting the source of fossil fuel. So, with time, if we do not come up with alternate methods to generate monomers from which polymers can be made, we will be in trouble, that we will probably go out of stock of making monomers, this fossil fuel. The small number of monomers can be made also from renewable resources, like say if you talk about some food materials or which are not used for eating application, for eating, it can be used for generate, some process can generate some monomers, but that probably is the very small fraction of monomers are made from renewable resources. So, now one of the present focus of research is how to get monomers from renewable resources, which means that we get monomers from a source which we can basically regenerate. The other problem, as I said, that the disposal of this polymers to waste. Polymers are not biodegradable. So, you cannot just throw these polymers and expect that it to be decomposed with time. The very advantage of the polymers, it is stable in normal conditions, it is water resistant. So, those basically the good qualities of the polymers are turning out to be the bad thing during waste, because it's very stable, it is not degradable. So, this is a problem, and this is why. So, basically if unless we do not manage waste properly, like the small polyethylene packing bags what you buy from shopping market, and then you throw them in the road, and then it with time it gets and get into the drains, because it's basically, if it is not degradable in the drains, it choked the drains, and then you get a problem. The other problem is that these bags, sometimes the cattles, cows, they basically eat them, and because it is not degradable, so it basically cause lot of harm to those animals. So, the problem area is that this waste, how to convert the polymers to a waste, and this is where we need, and lot of research are presently going on to make biodegradable or bioerodible polymers. So, basically which will be able to convert the final product, polymer product, after use. When you waste, it should be able to decompose in the environment. So, basically as I said, there are other areas of research are also active, but the main two focus would be here at the starting point and the ending point. How do you make monomers which are from non renewable resources, and how to you get polymers which are biodegradable in environment. So, by then this time I hopefully I just able to convince you that you should study polymer. And before I go to the next section, I just need to tell you that sometimes polymers also called macromolecules. These are synonymous. So, polymers are also macromolecules, and the origin of the name polymer is from a Greek term poly plus mar, which means many, and this means units. So, by this time you are aware that polymers are made from monomers, which are called units or repeat units when they form a polymer chain. So, a polymer is consist of many units, okay, and the units derived from monomer molecules. Now, we will go and basically study different types of polymers, different or basically classification. Now, there are many ways you can classify polymers, and the first one would be based on source. Obviously, in this case you have natural polymers, examples would be proteins. All our body is made up of proteins. We have nucleic acids, like DNA. DNA is the polymer which carries genetic informations from one generation to another generation in living beings. There are lot of natural polymers are cellulose. Natural polymers are basically, by this time you probably guessed, is basically the polymers from plants So, basically the polymers which are obtained from plants or animals. Cellulose is very common, and all the structural ingredients in trees and plants are made up of cellulose. Similarly, starch is another natural polymer. We can think about wool, cotton, silk. These are all natural polymers, and one important natural polymers is natural rubber, which are obtained from rubber tree, which is very much abundant in Kerala. Those which can be used as many applications. So, this is the first example. When you differentiating or classifying polymers based on sources, the first type is natural polymers. Again, the natural polymers are the polymers which are obtained from plants or animals or living resources. Second example or second type is obviously natural, and then second would be synthetic. Synthetic polymers, obviously as the name suggests, synthetic polymers are the polymers that are synthesized in lab or say plants, reactor plants I am talking about. This is not the tree plants, that plant, this is the the reactors and those plants. Example would be like plastics, like polyethylene, synthetic fibers like nylon 66, synthetic rubbers like Bunaes. The third type is in between. So, we had completely natural polymers, synthetic polymers, and the third would be semi synthetic polymers. So, in this case natural polymers are chemically modified to get useful polymers. So, in this case basically you are mixing a natural thing, taking a natural polymer and then doing some reactions in the lab or in a plant to get a useful polymers. For example, it would be cellulose acetate. Basically, you take cellulose and do a chemical reaction, and this is a rayon. Other example would be cellulose nitrate, etc. So, these are the examples of. So, we talked about natural polymers and then synthetic polymers and then semi synthetic polymers. Now, in this context, I just want to bring your attention some little bit of history of these polymers. Obviously, we had no clue about polymers even till early 1900 or around 1900. Before that, we have no clue, or we couldn't identify the what is a polymer. As early as 1861, British scientist Graham he basically was trying to dissolve some of the polymers, some of the organic compounds in solvent and filter it out. So, he found that cellulose, it dissolved and in the solvent and found that cellulose was not completely going through even the finest filters without leaving some gummy residues. So, basically he named, it was like glue, it was like a so he thought it's something like glue and named that in that time he named as colloids. After the Greek word kolla, which is meaning glue in Greek. So, this was the first time somebody noticed that there is something sort of a molecules which dissolves, but do not pass through filter papers. Even and in around 1870, when American inventor John Wesley Hyatt, he basically first chemically modified cellulose and then reacted. Basically, you got, he chemically modified cellulose to form cellulose nitrate and reacted with camphor at high temperature and high pressure. You get a material called celluloid. You probably heard this term celluloid. This is the material which was used to record movies silent, the old silent movies. That is why you probably heard the term celluloid. That was the first, basically it was the first plastic walls, basically walls. This was walls first plastic material. Now, just note the term plastics we are using in this case. The plastic means the term plastics is from a Greek word called plastikos, which means moldable or formable. So, in this case that celluloid material which he got, it was solid at normal temperature, but when it was heated it will behave like a molten liquid, and you can take that material and give or mold into different shapes. So, that is specifically what the term plastics means. Plastics is in by literally meaning is called moldable or formable. So, a polymer material, polymers which can be softened and given at different shapes or mold into different shapes, and which can be reversible. So, if you so basically you can do it many times, this cycle is called plastics. So, that was the first 1970, we talked about 1970, that was the first world plastic material was discovered, but this was not a completely synthetic, because it was started from a cellulose which is a natural polymers, and then modified by John Wesley Hyatt, and so that was not a completely synthetic, but it was indeed the first plastic material. In 1890, first synthetic or semi synthetic, you can say, textile fiber was made from by spinning, was made by spinning cellulose nitrate. This is the first synthetic textile fiber which was marketed, which came in the market as a product. Okay. And then about 1907, we got first completely synthetic polymer product was introduced in the market by Leo Hendrik Baekeland, and the name of the product was bakelite, and which was formed from phenol plus formaldehyde. Okay, so this was formed. So, this is the first completely synthetic polymer products which was introduced in the market. There was previously, probably it was reported in the literature that this can be observed, that it was observed by scientist named German scientist Adolf von Baer, that if you mixing phenol, by mixing phenol the normal disinfectant plus formaldehyde, they reported that this gives a product which is not a product which is not soluble in solvents, not fusible. So, this was reported before the introduction of bakelite at 1907, but 1907 was the first product in the market was introduced based on first completely synthetic polymers, and that was the starting of polymer age. So, from that we begin our journey in polymer age. So, this was little bit of history, and because we talked about synthetic polymers, semi synthetic polymers. So, you can see that at the beginning we had dealt with cellulose natural polymers, and then around 1870 celluloid was marketed, which was basically a semi synthetic polymers from cellulose nitrate, and then we finally had a polymers which was based on completely synthetic polymers. So, this is a little bit of history I wanted to share on development of polymers. And so, we were continuing our discussion on classification, and we did in the last case, we, as you can remember, that we basically did based on source of the polymers, whether it is natural, synthetic or semi synthetic. So, next number 2 we will move classification is based on structure. So, here I just want to take a minute and show you, generally we will write polymers like this. Why do we write like this, not a straight line? We do not typically represent polymer as straight line, this is not what to do. See, if you think about a polymers which has a C backbone, carbon backbone. Now, if you can think, imagine little bit that when you have carbon which is a tetrahedral bond, the next bond will come at an angle of 109.28 degrees, which you cannot put a straight line in this case. Obviously, this is a straight line, but the third one, when you talk about the third one, again you have to put an angle of 109.28 degrees, not a linear, not a 180 degree. Okay. Now, this will go in, you can think about in this, I am writing in 2 dimensional, but you can think that this can go behind this page of paper, or it can come up the page of paper as in, and this bond, single bond, you can rotate the polymers. So, you can get many possible what we call conformations of these polymer molecules, and none of them will be just straight this, because as the bond angles are not 180 degree, none of those conformations will be just exactly on same line. So, that is the reason what we why we write this as structures like this, somewhere like this, not as I said line. With this introduction, we can now classify the polymers based on structures as linear polymers, which basically chain of polymers with no branching. So, that A. Second is branched polymer. Now, in case of branched, you can have three types. One, you can have short branches. I can use some other color. So, these are short branched. You can have large long branched, or third type you can have, sorry, the colors, I should have used the other color. These are the branched, which are further branched. So, these are called hyper branch, where there are branches from the branches. So, you can have a short branched, we can have long branched, and we can also have hyper branched polymers. And the third in this category would be cross linked or networked polymers. In this case, the chains you have many chains. These chains are cross linked between them. And if the cross link is slightly, so basically you have different regions of cross link, then we can just call lightly cross linked polymers. And when the cross link is such extent that all the chains are now connected, like the example here I have shown, all the chains, these violet color chains, they are all connected through some covalent linkage between the chains, which are shown in black here. So, I can put many other chains here and put some black. So, in this case basically you have a giant polymers. So, basically all the polymers are connected, and because they are connected, they basically form a single polymer, which have a giant, very high molecular weight. So, we call a giant polymer, and this is called network polymer or highly cross linked polymers. So, with this what I will stop in this class, and in the next class I will continue my discussion on classification. So, basically we did start about polymer classifications, and we talked about polymers classification based on source, and we talked about based on structures, and we will continue in the next class what are the other classifications which we can differentiate the polymer molecules. Okay. See you in the next class.